BloodEye, which is very recent as well as innovative. In the comparison, we have mentioned existing system as a fingerprint based one, proposed system as a eye based one. Part of the image which contains the blood vessels, so that's called as Sclera image, using two type of images. So you can see Sclera images. So training has been started. Please wait. Go to the terminal. You can see the training here. So this is the white part of the image. I'm going to extract the feature from the Sclera image. Just extract that.
Hello everyone. Welcome to Ieee Xpert. Last year, we made a project on blood group detection using fingerprint. That project became super viral and it's still going strong. We were surprised to see more than 500 research papers published about it. Many students asked us, can we do any advancement on that particular project? And here is the answer. Blood group detection using eye images. Is it possible? Can it really work? Yes, we made it possible with our research. In this project, you can upload an eye image and it will detect the blood group. We were using two types of eye images. One, Sclera image, the white part of the eye. Retinal image, inside back part of your eye. In this project, by uploading the eye image, it will extract 10 special features from the image and it will detect the blood group. Amazing, right? The most important part of the project was the data set. We were collected around over 2000 plus eye images to form the data set. Also, we have achieved nearly 99% accuracy with the help of proposed deep learning algorithm. In this video, I will explain everything. This video having three parts: the base paper explanation, the complete PPT explanation, and complete demo of the project. Let's move on to the project video.
So first of all, I can show you the base paper explanation and PPT explanation. For that, we have to go to the project folder. So this is the project folder. Inside the code section, you can get the complete source code with the data set, everything present over there. Okay, you can get complete details over here. So we can go to the document folder. Inside the document folder, so this is the base paper. The complete report is there. Complete PPT is there. So this is the project base paper. This base paper published on IEEE 2025 year, which is very recent. You can find the year here. So August 13, 2025. This is the date it's published. Non-invasive technique for fingerprint-based blood group identification. This is the project base paper title. So from the title itself, you know that they have used fingerprint as an input. Based on the fingerprint, they have predicted the blood group. But this is existing. We can go for the proposed system. So this is our proposed system, blood group detection using eye image. So this is our proposed system. We have to see the comparison between the existing system as well as the proposed system. So this is the existing fingerprint based one, the proposed system eye based one. So this is the clear cut difference between these two. First of all, we have to see the base paper. In the base paper, they have used fingerprint. So which is very existing. The major problem present in the fingerprint based identification was the fingerprint was subject to the environment changes. Okay, so if you are the hard workers relevant to the if you are using some coolie type of works like that, means your fingerprint may be damaged, it's corrupted. Okay, so the real life fingerprint data won't be accurate for those people. Okay, so why? Because they are using their hand for their works daily. So even if you are the typewriter, your fingerprint data may be reduced over the time to your ears. Okay, so that's why we are not trusting this fingerprint based work. And one more drawback is security. Wherever you're going to scan your blood group, means you have to scan your fingerprint. So you are providing your fingerprint to the unauthorized usage. This will lead to many security problems. That's why we are not suggesting this fingerprint based technique. We are going for the eye based technique, which is very higher, very accurate. Okay, eye based technique is very higher. We are not using any iris here. You have to note this point. We are not using any iris, so it's not belong to the security issues. So we can see the difference between the proposed system and existing system in this PPT itself. Clear cut difference. I can explain the PPT for you. The project titled as BloodEye, which is very recent as well as innovative. You can get the title blood group detection using eye image. Simple and clear cut title. Combiningly, we have mentioned as a BloodEye. I can give the comparison first of all for you all. So here is the comparison. In the comparison, we have mentioned existing system as a fingerprint based one, proposed system as a eye based one. You can see the accuracy between these two. The existing system accuracy producing 96%. using CNN, the proposed system produces accuracy 98.7 using deep convolutional neural network. This is the clear-cut difference. The existing system uses convolutional neural network. The proposed system uses deep convolutional neural network. Why? Because it's producing higher accuracy. The existing system uses fingerprint image as a input, but our proposed system is a multimodal biomedical input. What's the meaning of multimodal imaging? Means you are using two images here, fundus image as well as sclera image. You are using two images. That's why it's producing higher accuracy. Data accessibility. The existing system needs specialized high-end fingerprint scanner, which cost you around 80,000, 90,000 like that. Also, it won't applicable to the normal fingerprint scanner. You need high-end finger imaging device to scan this output and that. And one more thing, there is a security issue if you are providing the fingerprint to the third parties users and that. But proposed system, we are using eye images. It's not relevant to the any iris images. We are using retinal image as well as the sclera image. So here is no security related issues. And one more thing, personalization. The existing system, very limited personalization approach is available. You can't modify the data and all, but proposed system will support tons of specialization, personalization and all. Why? Because we are considering nearly 10 number of features in our proposed system, but the existing system uses only one feature, fingerprint ridge pattern. But proposed system uses nearly 10 features. Why? Because it produces higher accuracy as well as it supports tons of specialization as well as the personalization approach. Okay. So this is the clear-cut difference. You have to know what is the sclera image and fundus image. I can show you this content for you. So this is the sclera image. What's the meaning of sclera image means? The sclera means that the outer white part of the image. So the white part of the image which contains the blood vessels. So that's called as sclera image. So from the sclera image, you can get sclera data, blood vessel data, as well as corneal border data. These three data you can get from the sclera image. And one more image we need was fundus retinal image. So this is the fundus retinal image. We have to get this image via fundus retinal camera. So from the fundus image, you can get retina details, optic disc details, as well as retinal blood vessel details. It used to find the thickness value as well as the contrast values and all. So these two images we need, sclera image and fundus image. Let's move on to the project abstract. Okay. So this is the project abstract. This project abstract, simply we are mentioning that here we are using deep learning based feature extraction method, which is used to predict the any person's blood group. Okay, that's what we are going to provide with this project. The major problem which this project solved was the traditional blood group test requires invasive method. What's the meaning of invasive method? Means you have to provide your sample. You have to provide your real-time blood sample that contains time consuming, which is very uncomfortable. Even if you are the 1 year baby, if you are going for the 1 year baby and all, means they have to take some blood from the 1 year baby. They have to use specific needle. From the needle itself, many type of disease may spread like AIDS or something major disease may be spread with the needle. They are not handling the needle cautiously or safely, means there will be chance of disease spread. So we have to overcome this with a non-invasive method. What's the meaning of non-invasive method? You no need to provide any sample. There is no need of any injection or no need of any needle. Just imaging is enough. Photograph is enough. That's called as non-invasive. That means simply touchless method. There is no touch involved with you. Okay. So tech stack involved in this project. We are going to use plenty of algorithms in this project. For example, we are going to use deep convolutional neural network for feature extraction, PCA, principal component analysis, Flask based web application. Also for data storage, we are using SQL here. Plenty of stacks using in this project. This project is a user-friendly web application platform from where any patient can feed their data, they can check their blood group. Okay, it's a very user-friendly one. So let's move on to the features present in the project. This project having three main features: dual image input. You can support both retinal as well as sclera input image. It supports both the images. Automated feature extraction. You no need to mention what type of feature you need to extract and all. It will extract all the features automatically. For example, vascular density, tortuosity, redness, blood vessel redness, hue value, and it will extract nearly 10 features from the two images. Instant prediction. It won't take nearly 1 minute, 2 minutes, or 3 minutes. It will give the result in a seconds. Okay, within fraction of a second, it will give the result as well as the accurate result. That's the major features of the project. Let's move on to the existing system. As we mentioned earlier, the fingerprint-based blood group detection we are mentioning as the existing system. It's require high-end finger imaging device which requires high cost. Also, it's not fully non-invasive method. Okay, maybe some blood group detection methods need your blood sample also. Also, the existing system fingerprint-based accuracy was heavily influenced by the image quality. Even if you are having a your image finger pattern is not visible, means your blood group data may be inaccurate. So it heavily depends upon the image quality. Also, the convolutional neural network they have used was very low accuracy. It's producing 96.4% as training accuracy. Validation belongs to 80%, which is very low. Okay, so the major drawback was there is a 4 problem involved in the existing system. So it's an invasive method. Maybe the existing system requires blood sample. Lab test can take some time. You are providing your blood to the lab, means they will take around 15 minutes, 20 minutes to get your blood group result data. Risk of infection. If you are going for the fingerprint or blood sample based detection, means there may be chance of disease spread. Okay, there is no digital record. They are not maintaining any digital records, but our project is a web application. It maintains the record. So there is a drawback of the existing system. So coming to the comparison, I already mentioned all the difference between the existing and proposed system in this video itself. So coming to the proposed system, so this is our interesting proposed system. This proposed system suggesting the Fundus, that means eye-based blood group detection, which is very, very first in the world. This is a completely novel research. You can't get this research anywhere. First time we are publishing this project, okay, in a YouTube or everywhere. So even if you're going for the blood group based fingerprint based blood group detection, we only publish that video first and first. Okay, so everyone go through the video, everyone bought the project and everyone made the research. They have published tons of papers with that paper which the video we have published. So coming to this year, we have to come up with a new concept, blood group detection with eye images. So note this down. Okay, this video going to rule the research market. Okay, research market, everyone going to do the research on this topic, but we only having the data set. Keep that project in your mind. Okay, so image acquisition. So we require this project, we require 2 type of images, Fundus images and Sclera images. 2 type of images we need. So already we have mentioned what's a Sclera image and Fundus image. We have mentioned that. So you can get this here. So this is Fundus Sclera image. This is Fundus image. I already mentioned that. So also in this training, we are going to use deep convolutional neural network. With the help of deep convolutional neural network, we are going to achieve accuracy of 98.6 and validation accuracy of 98 when compared to the base paper, which is higher. Okay. Also, we are going to get confusion matrix, loss ratio, accuracy ratio, everything with this project. Okay. So this is completely non-invasive method. That is touchless blood group detection method. So here we are going to use many algorithms. So first, for feature extraction, we are going to use principal component analysis. For data pre-processing and loss ratio overcome, we have to use standard scalar for dimensionality reduction. And overall data training, we are going for the deep convolutional neural network model. Okay, so this is the overall algorithm we are going to use. Coming to the feature extraction, we have to use multiple features. For example, blood vessel redness, blood vessel thickness, as well as blood vessel density, AVR ratio, tortuosity, redness level, hue difference. We have to use nearly 10 features with the help of proposed system. So this is the features we are going to use. So this is the Fundus image and Retinal image. I mentioned everything earlier. So this is the pictorial diagram of the project. You can see the overall flow. First of all, you have to upload the Fundus image. If you are uploading the Fundus image, what it will do means it will directly go to the feature extraction part. Inside the feature extraction part, we have to extract many features. Okay, AVR, blood vessel thickness, CNN ratio, everything we have to extract the features. Then we have to apply the pre-processing, data pre-processing using the standard scalar model. So coming to the next step, you have to apply the Sclera image. If you are uploading the Sclera image, it will extract same mean Q value, redness value, as well as the vessel density. It will extract same feature. These features will pass to the deep convolutional neural network model. Combiningly, with the help of both features, we have to predict the blood group. You are having AB blood group. You are having B positive blood group. Like that, the result will appear. So coming to the admin part, the admin have to upload the data set which contain all the 10 features, then have to apply the pre-processing step, then moving to the feature extraction. Finally, you have to train with the help of deep convolutional neural network and have to say the pre-trained model. This pre-trained model only compare with the testing model. Okay, this is the overall pictorial diagram. So architecture diagram also given. So if you are not convenient with the pictorial diagram, if your college is asking block-based features, go to this block-based diagram. Okay. Now, coming to the advantage of the project, this project produces 4 different advantages. First of all, this is non-invasive, no needles, no touch, completely touch-based blood group detection, fast and efficient. It will produce a result within a fraction of a second. Also, it's accurate. Okay. So then retrainable. You can add more values to the data set. You can train, depends upon your, even if you are Indian, even if you are Asian, even if you are European, you can add over all the data. You can train your model again to produce a better accuracy. So coming to the models, this project having 8 models, overall 8 models present in the project. So user authentication module, that means login registration, image upload module, you have to upload the 2 type of image, fundus as well as the retinal image. Feature extraction, you have to extract 10 different features, okay, vessel density, AVR, tortuosity, redness level and hue variation, nearly 10 features you have to extract. Then you have to apply the pre-processing using the standard Sclera model. Coming to the model training, you have to apply deep convolutional neural network to train all the data. Finally, the prediction module, user can upload their own image, retinal as well as fundus image. They can check whether they're having what type of blood group they're having and that. Then visualization model, it will display about the accuracy, loss ratio and confusion matrix and everything. So the 8th module belongs to the admin module. They can retrain the data set. Even if you want to add some new data with the data set, they can add, they can retrain or reproduce the result completely. So this is the admin module. So overall 8 different models present in the project. Okay. So this is the hardware and software requirement. To implement this project, we need 4 GB of RAM is enough. This is very basic. Even the i3 processor can able to run this project. Coming to the software part, this software part we have to use Python based software we are going to use. For front-end application, we have to use HTML, CSS and JavaScript. For website making, we are using Flask here. Coming to the storage, data storage and all, we have to use SQL database. So this is the conclusion. This project produces nearly 99% accuracy, which is very higher compared to the proposed system, existing system. As well as we are using many pronounced well-known algorithms to achieve the better accuracy. That's called standard Sclera model, deep convolutional neural network. Even we are applying PC over here. So this model will eliminate the invasive based blood group detection. This is completely non-invasive, painless model. You don't feel any pain while detecting your blood group. As well as this is strong potential for medical emergencies. Even if you are the medical researchers, you want to procure some advanced research, means here is the project for you. Okay, so this is the reference, overall reference involved in this project. Keep connect with this video. We are going to the very interesting part of the video. We are going to see the live demo of the project. So just run the live demo here. So to run the project demo, I have to go to the code folder. So this is the overall project code folder. You can find the data set here. In the data set, we have used 2 type of images for all the data set. You can see we have used Sclera image as well as the retinal image. For all blood groups, we are using 2 type of images. So you can see Sclera images as well as retinal images for all blood groups. Okay, you can check everything here. For all blood groups, we have used 2 type of images. Then we made feature extraction. With the help of feature extraction, we made the finalized data set here. So this is our finalized data set. We have made the feature extraction and combiningly we formed this data set. So this is the data set, finalized data set with the help of images. You can see the subject ID and then the specialized image ID, then its fundus image or else Sclera image. 2 type of images we have mentioned, right eye image or left eye image, that also we have mentioned. Then captured date, everything mentioned here, captured date and all. Then what type of camera used to capture the image, everything mentioned here. Okay, then features For all images, we have extracted feature and we have mentioned the features. 10 features we have mentioned. You can see the features details also here. Okay, this is the features. I can explain the details features here. So these are the features we have extracted from the images. So here, so CNN PSA value, AVR value, vessel redness value, Sclera mean Q value, AV saturation differentiation, tortuosity, then Sclera redness, vessel density, then pervascular contrast, pulse rate. So these are the 10 features we have extracted from the image. Then we have defined the blood groups from the data. So this is the data set. We will apply the prediction on our project. Let's see. Okay, so this is the complete data set we have trained. So to train this particular model, we are using deep convolutional neural network. So this is the training code we have used. So you can find the training code on our project folder. So this is the training code. So see that. So we have used the data set here. So this is the data set. We have used dataset.csv. We have called this. So we have extracted features from that. So this is the features. From the features, we are going to predict the blood group. Okay. Then we are using pre-processing, data pre-processing and feature extraction. Then standard scalar model and everything. So using the standard scalar model, we have done the feature arrangement. Then so we have trained the model. So here you can find the training and all. So this is the overall model which we are going to use. You can see the accuracies and all. So this project produces 96.25. Then the pre-trained model and everything got stored. Trained model H5, scalar PKL, then encoder PKL. These things stored. Then you can find the accuracy graphs. So this is the accuracy graphs and all. So this is the last graphs we have achieved. Then confusion matrix also given over here for all the blood groups. Confusion matrix given over here. Then accuracy and precision recall accuracy values. Everything given here. So you can check nearly 96% accuracy we got. So for each blood group, we have mentioned the F1 score, recall score, and precision score. Then overall feature independent graphs. So this is the features independent graph. What are the features representative for each and every blood group? Feature representative. So this is the overall training. So this is not only the project. Going to the important part, I'm going to run the project and check the real-time blood group detection. For that, we have implemented the front-end part. So this is the front-end part. We have created the HTML codes for that. This is the main code app.py. I'm going to run this code to check the things. So to run the app.py, I'm just copying the project location. Once I copy the project location, I'm just going to open the Anaconda Navigator, then open the terminal. Just type cd space project location. That's enough. Just type, that's it. Going to type python space app.py. So this command will run this particular code. If there is any error, it will show the error, or else it will run the project. So just type python space app.py. Just I'm entering error. Just click. Okay. So the project is executing now. If there is any error, it will show the error. So waiting for the code to compile. So that's it. It's running on this location. Okay. So the project is running. Just click this link. So this is our home page. You can see the home page here. So the home page we have mentioned as predicting blood group through eye image analysis. This is completely a non-invasive diagnostic method. Okay. So you can see we are using data pre-processing, feature extraction, blood group prediction, and training and analysis. Everything given over here. So this is the home page. So first of all, I have to register. So to register, I have to give any name. I'm going to use Kumar. I'm going to use Kumar. Password 123. I'm going to use 123. Kumar 123. Just click register. So once registered means data will store on the database DB. So here is the user.db. It will store here. So I'm going to log in with Kumar. Password will be 123. I'm going to use. Just click login. So password 123. Just log in. Now, so login got successful. Okay. So now go to the working. So this is the working of the project. You can check the project workflow here. So we are given what is the each and every steps involved in the project. For common people, we have created this page, how to understand the working and all. So image acquisition, pre-processing, feature extraction step, feature combination step, then model input, prediction, evaluation, result, display. So 8 different steps involved in this project. Also, for each and every features, we are given the definitions also. You can check. What's the meaning of fundal vessel density? What's the meaning of fundal tortuosity? What's the meaning of fundal disc diameter? Then what's the meaning of macular brightness, retinal ridge counter? Everything mentioned here. Okay, clearly everything mentioned here. So if you are admin, you can train also. Just click here, training. Just upload the data set. You can give training also. Just go to documents, project scripts, blood group detection with eye image, then select your data set. Just data set, click here, start retraining. So training has been started. Please wait. Go to the terminal. You can see the training here. So it's live. Training is going on here. Just wait for the training to complete here. We have applied nearly 150 approaches. You can increase the approaches also to achieve the better accuracy. So that's it. Training completed. Completely training completed. Now we go to that. Training and evaluation completed. Check the accuracy page for results. So here is the accuracy page. Just click here. You can check the accuracy. So nearly we got 99% validation accuracy, 98% on training accuracy. So this is the loss ratio. This is the confusion matrix. Everything given here. You can train your own data. Okay. So without wasting time, I'm going for the prediction page. Here is the prediction. First of all, what I have to do, I have to upload my fundus image. Just choose this. Go to the document. Inside the document, Python script. Here is the blood group detection with eye image. Here's the code folder. Then test image. I have saved multiple test image for testing purpose. Randomly, I'm selecting this image. So this is the image I have selected. I have to extract the fundus features from that image. Just click extract. So it starts scanning the image. It will extract the fundus features. I'm waiting for the fundus features to extract. That's it. This is the fundus AVR value, fundus CNN value, fundus tortuosity, then fundal vessel density, fundus vessel redness. The feature have been extracted. Move on to the next step. Upload Sclera image. So here is the Sclera image. Just you have to upload the Sclera image. So this is the white part of the eye. Just I'm selecting this. I'm going to upload this. So this is the white part of the image. I'm going to extract the feature from the Sclera image. Just extract that. Start scanning. That means start extracting. That's it. Within a fraction of a second is extracted. Sclera AVR value, Sclera CNN value, Sclera mean Q, then Sclera contrast, Sclera redness. Everything extracted. Move on to the final result. Now I'm going to see the blood group value within a fraction of a second. Just that's it. So this is the combined features. Overall we got 10 features. So here is the 10 features from the fundus and retinal image. You can check the final result. Predicted blood group was AB negative. Okay, the prediction based on combined fundus and Sclera features. So this is the working. It's perfectly working. Let's move on to check another image. Just click prediction. I'm going to upload different Sclera image now. So this time I'm going to upload this image. So just click extract features. Scanning started. So wait for the extraction to complete. It will give the result in a second. So this is the features from for that particular Sclera image. Just upload Sclera image. Just choose different image now. I'm going to choose this image now. So this is the Sclera image I'm going to upload. Just extract the features, start a scanning. It will give the result in a second. Okay, that's it. So this is the Sclera features. Just check the final result. A negative. You can check the results. So A negative. So this is the combined feature. Let's move on to check another image now. So I'm going to upload different image. This image. Extract the feature. Once feature extracted, upload the Sclera image. So this time I'm going to upload this image or this image. So this image, extract the feature. So feature extraction completed. Result AB positive. Okay. So this feature will compare with this feature data set. it will give the results. Okay, let's move on to the interesting part, analysis. In the analysis, you can get the overall result. What are the features involved in this project for all the blood group? So for A positive, what's the PCA value you can expect? For B positive, what is the CNN PCA value you can expect? If you are O positive, what are the AVR value you can expect? So if you are the B negative, what other blood redness you can expect? So this is the combined AB saturation value. Okay, what's the AB saturation for A positive blood group? What's the AB positive blood group for AB saturation value? You can get all the result, feature graphs. Okay, toxicity value. So I can explain the B negative blood group having highest number of toxicity value. Same goes to B positive having lowest number of toxicity value. Also this, from this graph you can check. So B negative and B positive having highest number of sclera mean. Okay, highest number of sclera mean. Then AB positive and A negative having lowest number of sclera mean. So then move on to the another graph, blood vessel density. The blood group O positive having higher number of blood vessel density. The blood group AB positive having lower number of blood vessel density. Same comes here. The vascular contrast, B negative having highest number of vascular contrast. Then AB negative, AB positive having lower number of vascular contrast. This is the blood pulse value. AB positive having lower number of pulse standard value. Then O positive having highest number of pulse standard values. From these features only going to extract the blood group value. So this is very interesting project. To get this project, you have to go to the IEEE-Xpert.com website. Link is given on the description. Here you can find all the interesting projects with complete abstract, complete video, and complete demo. You can check our website for getting this project. Okay, thank you.